Hi everybody, in this video I'm going to talk about the sum to the n term of a geometric progression. So here are the few formulae that we need to remember. Sn equal to a 1 minus Rn over 1 minus r, and r is less than 1. When the r is less than 1, we will prefer to use this formula. If let's say when the r is greater than 1, we will prefer to use another formula, which is a Rn minus 1 r minus 1. But actually you can interchange them. For example, when the r is greater than 1, you don't want to use this formula, you want to use this formula, you will still be able to get the correct answer. Okay, let's see how do we use these two formulae to help us to get the sum to the n term. Find the sum of the first 8 terms of the geometric progressions of this number sequence. We have 4, 12, 36, and so on. Okay, so the first term is 4. The common ratio, r is a common ratio. When you want to find the common ratio, remember, you take the second term divided by the first term, or the third term divided by the second term. 12 divided by 4, which is equal to 3. Now you have the first term and you have the common ratio, then you should be no problem to get the sum to the 8 terms. So at the beginning, it's better that we write the formula for a few times so that we can remember the formula well. Since that the r is greater than 3, greater than 1, I will prefer to use this one. A Rn minus 1, r minus 1. Sum to the 8 term is equal to a. What is the value of a? 4. R equal to 3. N equal to 8 minus 1 over r minus 1. R is equal to 3 minus 1. Okay, so this one you just use our calculator to help you to get the answers. Okay, the answer is 13120. 13120. Okay, let's say if you don't want to use this formula, you want to use another one. Now the r is greater than 3, right? The r is greater than 1, right? Okay, just now I use this formula. How about now we try using this formula, see whether we can get the same answer or not. A 1 minus r power n, 1 minus r power n, 1 minus r. Okay, you try use a calculator check, you will exactly get exactly the same answers. Okay, now the r is 3. The r is 3. So this is 3. Oh. Yes, you will be able to get exactly the same answer, 13120. Okay, so now let's proceed to part B. Okay, let me copy down the number sequence first. You have 16, 8, 4, and so on. Now the question is asking about S7. So same thing, we need to determine the value of A, which is equal to 16, and the value of R, common ratio. When we find the common ratio, remember, not take the bigger number divided by the small number. Sometimes you will need to take the small number divided by the bigger number. Just remember, you take T2 divided by T1, or if you don't want, you can take T3 divided by T2, or T3 divided by T4 divided by T2. All will give you exactly the same common ratio. Okay, so in this case, how about I use a small number? I take 4 divided by 8, which is equal to 1 over 2. Now I have the common ratio and I have the first term, then I will have no problem to find S7. Okay, so S7, I will use this formula. A, what's A? A is 16. 1 minus r. R is 1 over 2. So 1 over 2, you can actually write 0.5. It's the same thing. Raised to the power of n is 7. over 1 minus r is 0.5. Okay, just use a calculator to calculate this part. The answer is 31.75. Okay, let's try another example. Given a geometric progression, we have 840, negative 630, 472.5, and so on. Find the sum of all terms from the third term to the sixth terms of the geometric progression. Means that the question is asking us to find T3 plus T4 plus T5 plus T6. So, okay. In the arithmetic part, we also learned about something like this, right? Just we use different formula. So if that part you have no problem, that's one you should be able to get the correct answer. So we don't want the we don't want the T1, T2, okay. So these two we don't want, right? We only want T3, T4, T5, and the T6. This is the part that we want. So what should we do? We take sum to the sixth term, T1 under T6, minus S2, T1 plus T2. Then the rest, we will be able to get this part, right? Okay. So it means that now we need to find S6 and S2. Okay, let me do it separately. Same thing, I need to determine the value of A first. The value of A is 840. The value of R, take this one divided by this. Okay, press the calculator, 630 divided by 840. You will have a negative there. Okay, negative 0.75. If you don't want to write this way, you can write negative 3 over 4. Same thing. Okay, so now we have the common ratio and the first term. It's very easy for us to find S2 and S6. Okay, let's find S2 first. S2 is equal to A 1 minus Rn. R raised to the power of n. 1 minus, so negative 0.75 raised to the power of n. N is equal to 2. Okay, so this one I think I changed this to this. Over 1 minus R. Okay, so just press our calculator. You will be able to get 210. 210. Okay, now let's go to 5S6. Using exactly the same formula, now just plug in, we just change the value of n. So A 1 minus negative 0.75 to the power of 6 over 1 minus negative 0.75. Okay, just press the calculator, get the correct answers. 1 minus, okay, negative 0.75 raised to the power of 6. Okay, this is a very long decimal. You can change it to a fraction, which is equal to 394 and 73 over 128. So now we are looking for S6 minus S2, right? S6 is equal to this 394 and the 73 over 128 minus S2 210. Okay, so the answer is 184 and 73 over 128. Okay, so this is the final answer for this example. The sum of the first n term of a geometric progression is given by this. So you will notice that just now we didn't have this formula, right? This formula is only applied for this particular geometric progression. For this particular geometric progression, and the question tells us that we can use this formula to help us to get the sum to the n term only for this particular geometric progression. Okay, Sn is equal to this. We want to find the first and the fifth terms of the geometric progression. I hope that you still remember. T1 is equal to S1, right? And the Tn is equal to Sn minus Sn minus 1. Means that if I want to find T5, I need to find S5, then minus S5 minus 1, which is equal to 4. Okay? So now let's find the first term first. T1 is equal to S1, right? Okay, so S1 is equal to 4, 3 raised to the power of 1 minus 1. 4 times 2. Okay, so the first term is equal to 8. Okay, now let's find the fifth term. T5. So T5 is S5 minus S4, right? Okay, let me erase this one first. If you worry that you will get confused, mess up, you can actually do it separately. So how about I find S5 first? S5 is equal to 4, 3 raised to the power of 5 minus 1. Okay, just press the calculator. Here you will get 968. Now let's find S4. Same thing, use the same formula. 4, 3 raised to the power of n is equal to 4 minus 1. Okay, so this is 320. Now if I want to find T5, I just use S5 minus S4. So this is 8, 4, 6, 6, 4, 8. This is the fifth term. Okay, now let's go to part B. Find the algebraic expression of Tn. Means that we need, this is algebraic expression for Sn. Now, the question wants us to find the algebraic expression of Tn. Means that find the formula for Tn for this particular geometric progression. Okay. Okay, let me erase erase this one first, because later I'm going to use this one to test whether the answer for part B is correct or not. Okay, so Tn is equal to Sn minus Sn minus 1, right? Okay, so Sn, we just copy everything here. Okay, Sn minus 1. We change the n, become n minus 1. The rest we just copy. Okay, so this one I can actually do some expansion here. 4 times 3 power n minus 4. Okay, how about this? So 3 power n minus 1 is actually 3 power n over 3, right? Okay, and then I copy the 1. Okay, same thing here. I do some expansion. 4 times 3 power n minus 4 minus 4 over 3, 3 power n. This times this. Negative, negative become positive 4. Okay, so if now I can rearrange all the terms nicely, so easier for you to see how to continue. Minus this, so I have negative 4, and here I have plus 4. Okay, so now I have, you can just think this way, 4x minus 4 over 3x. So how many x we have now? So now we have 8 over 3, 3n. Negative 4 plus 4, no more. Okay, so since that this is 3, we can actually do this way, minus 1. Okay, now we got the algebraic expression for Tn, 8, 3n minus 1. So if we want to test whether this answer correct or not, we can do it this way. Since that I know Tn is equal to this, now how about T1? So now I try to plug in the 1 over here, see whether I can get 8 or not. T1, 8, 3, 1 minus 1. 3 raised to the power of 0 is equal to 1. 8 times 1, you get 8. Okay, correct. So how about T5? Let me check. T5. 8, 3, 5 minus 1. So you will get 8, 3 equal to 4. Okay, now use our calculator. 3 raised to the power of 4 times 8. 648. Yes, correct. So it means that this algebraic expression for Tn is correct. Okay, now let's try this another example. The first three terms of geometric progressions are k plus 1, k minus 3, and k minus 6. Okay, let me copy down first. K plus 1. This is the first term. K minus 3, second terms, and k minus 6, third term. Find the value of k. Okay, so this is a geometric progression. So what is the characteristic of geometric progressions? They have a common ratio, right? So since that they have a common ratio, you know that k minus 3 over this one divided by this will be equal to this divided by this. Okay, I hope that you still remember. If for AP T2 minus T1 is equal to T3 minus T2, that's for AP. They have a common difference. It's equal to T4 minus T3. Okay, let me check it out now. 2 minus 1, 3, 2. Okay, so when we have a geometric progression, it's not minus, but divide, because this is common ratio. T2 divided by T1 is equal to T3 divided by T2 is equal to T4 divided by T3, and so on. Okay, so now we need to find the value of k. We just do some cross multiplication. K minus 3 times k minus 3. This time this, and this time this. K plus 1 times k minus 6. Okay, so this you just do some expansion, or if you want to use this formula, still remember the formula for this. Okay, I write over here. A minus b squared. What is the formula? A squared minus 2ab plus b squared, right? Okay, so now we can use this formula how to get this part. So it will be k squared minus 6k plus 9. Okay, so how about this one? K times k, k squared, k times negative 6, negative 6k, positive 1 times k, positive k, positive 1 times negative 6, negative 6. Okay, so we try to simplify them. K squared minus 5k minus 6. Okay, so both sides we have k squared, we can actually cancel them up. Because k squared, I move it over here, k squared minus k squared, you will have no more k squared. Okay, so I group the k, I write all the k on the left hand side and all the number on all the constant on the right hand side. Negatives, okay, let me use back the blue color. Negative 6k plus 5k. Okay, negative 5k moves over here. And copy negative 6. Positive 9 moves over here, negative 9. Okay, so this will give you negative k. And this is negative 15. So from here we know k is equal to 15. Okay, we got the value of k. Okay, so how about part B? The sum of the first 6 terms of the geometric progressions. So we need to find at 6. So if we want to find sum to n term, we know we need the common ratio and also we need the first term, right? I know the k is equal to 15, then I plug in over here. 15 plus 1, you will get 16. So this is 16. 15 minus 3, 12. 15 minus 6, this is 9. Okay, 16, 12, and 9. Now, I know that the first term is equal to 16 and the common ratio is equal to 12 divided by 16. Three over 4, or you can write as 0.75 as well. Okay, now we have the value of a and the common ratio. We can get the S6 easily. So a 1 minus r raised to the power of n over 1 minus r. Okay, just press our calculator. Okay, the answer is 52 and 39 over 64. Okay, let's proceed to the next example. A company has said that each of its employees will receive a 6% annual salary increments of their basic salary for 30 years. Cindy, as an employee of the company, received a salary of 25,000. This annual salary, 25,000 in the first years. So in the first year, so it means that the first year is 25,000. So what the salary for the second year after the increments of 6%? So increments of 6%, it means that you need to times 106 over 100, right? Because increase 6%, and this is actually equal to 1.06. So it means that the common ratio for these questions is 1.06. Okay, now just take our calculator, try and see 25,000 times 1.06. Okay, so you will get 26500. Okay, let's calculate one more. So this is a salary for the first year, second years, and third year. Okay, so now the question asks you, what is her salary in the 30th 30th annual salary, annual salary. So it means that we need to find T30, right? Okay, so T30 is equal to, what is the formula for Tn? N minus 1, right? Okay, so that A is 25000. The common ratio is 1.06, and this is N is 30 minus 1. Okay, so 25000 raised times 1.06 raised to the power of 29. Okay, 25000. Okay, and the question asks to give the answer to the nearest RM. Nearest RM, then it will be RM 135460. So this salary is only the annual salary for that particular years. Okay, for part B, what is the total amount of a lifetime salary for the period of 30 years? So in this case, we need to find S30, means that the first year salary, first year annual salary, plus the second year, plus the third year until the 30th years. Okay, what is the formula? A 25000. R is 1.06, right? 1.06 raised to the power of N 30 minus 1 over 1.06 minus 1. Okay. Okay, when we round off to the nearest RM, then it will be 1, okay, RM 1976 455. Okay, so these are answers for these questions. Okay, now let's learn about sum to the infinity. Sum to the infinity. So the formula is A 1 minus R, and every time the common ratio must be within this range, more than -1, less than 1, so it means that 0 point something. Okay, so express each of the following recurring decimal as a fractions in its simplest form. In the previous, I think last two chapters, you also learned about this, but for that chapter you are using another method. Okay, so you remember this method. We let n, okay, let's say x equal to 0.6666. Okay, then how about I times 10. So this is the method that you learned previously. So it becomes 10x, and this will become 6.6666. Okay, so this is the first one, this is the second one. So after that, we want to eliminate this part, right? I take the second one minus the first one. I will get 9x, 10x minus x, 9x. And this minus this one, this part will actually cancel up. You will get 6. So x is equal to 6 over 9. X is equal to 2 over 3. So x is equal to this. It means that 0.6666 ... It's go indefinitely. It's actually equal to 2 over 3. So you can check by using your calculator. Press 2 over 3. 2 over 3. 0.6666 and so on, right? So this is the method that you learned previously. So now we are using this sum to infinity formula to help us to get the answers. Okay. 0.6666 is go indefinitely, right? I can say that this is actually equal to 0.6 plus 0.06, right? Plus 0.006 plus 0.0006. Okay, let me check around that. 1, 2, 3. Plus go indefinitely. So now we are looking for sum to infinity. I'm going to take this plus this plus this, go indefinitely. Okay, so the A is equal to 0.6. The R, this is the first term, second term, third term, fourth term, and so on. 0.06 divided by 0.6, you will get 0.1. So now we use this formula, see whether we can get this answer or not. So sum to infinity is equal to A over 1 minus R. 1 minus R. 0.6, 0.9. So you times 10, move the decimal one decimal place to your right hand side. This you do the same thing, 6 over 9. And we simplify, you will get 2 over 3. You get exactly the same answer. Okay, so this is the way how we use the formula sum to infinity to help us to solve this type of questions. Okay, let's try one more for B. Okay, now 0.12, and you see 2 dot above this 1 and 2 digit, right? It means that this 1 and 2 keep on repeating. 0.12, 1, 2, 1, 2, 1, 2, and so on. Okay, so this can be written as 0.12 plus 0. Okay, be careful here. It's not 0.012. This is not correct. If you try a thing, if you take 0.12 plus 0.012, you get this. You cannot get 0.121212 like this. Okay, so this is not correct. This should be 0.0012 plus 0.000012, and so on. It go indefinitely. And now we are going to find the sum of all of this, sum to infinity. A is equal to 0.12 and R is equal to 0.0012 divided by 0.12. Okay, you can press your calculator, you will be able to get 0.01. Okay, so now let's use this sum to infinity formula to help us to get the answer. A 1 minus R. Okay, now just press the calculator. over 33. So if you want to check whether correct or not, you can press the calculator. 4 over 33, then change it to decimal. 4 over 33, change to decimal. You get 0.12121212 and so on. So this is the answer for this part. Okay, let's try one more example for this video. For geometric progressions, the first terms T1 exceed the second terms by 10. It means that the T1 is more than T2 by 10. So it means T1 minus T2, you will get 10. Okay, the first term exceeds the second term by 10. T1 minus T2 is equal to 10. And the sum of the second and the third term is equal to 15. T2 plus T3 is equal to 15. This part. Given that the common ratio of the geometric progression is positive, find the common ratio. So we need to find the R, we need to find the A, and then we need to find the sum to infinity. Okay, what is T1? You know T1 is actually equal to A, right? So T2 is A, R, Tn is equal to A, R, n minus 1. So T2 is equal to A, R, 2 minus 1, which is equal to T2 is equal to AR. Okay, so this is 10. So I think I just factorize, bring the A go out. 1 minus R. Okay, 10. That will be the first equation. So how about this one? T2 is AR, right? AR plus T3 is equal to AR 3 minus 1, which is equal to AR2. So AR raised to the power of 2 equal to 15. Same thing, I do some factorization. I bring the A go up, minus plus, sorry, and this is R square. Let it be the second equation. So now I want to eliminate the A. I can take the second equation divided by the first equation. Second equation divided by the first equation. Second equation divided by the first equation. So you can cancel out the A. So this one you can simplify it, become 3, and this is 2. Now you have a quadratic equation here. So now we are going to form quadratic equation, then solve the quadratic equation. 2 times this. Okay, or I write again. Cross multiplication. 2 times r plus r squared is equal to 3 times 1 minus r. Okay, so I think I do it over here. So 2r plus 2r squared is equal to 3 minus 3r. Okay, we arrange all the terms nicely. And then this is plus 2r plus 3r minus 3 is equal to 0. Okay, so you will get 2r squared plus 5r minus 3 is equal to 0. So you can use your calculator to help you to do the factorization, or you can do it manually. Okay, so let me check around that. 2r minus 1 is equal to 0, or r plus 3 is equal to 0. R is equal to negative 3, and r is equal to 1 over 2. And if you go back to the question tells you that the common ratio of the geometric progression is positive. It's a positive number. So it means that this one we don't want, ignore it, or not accepted. So now we know that the common ratio is 1 over 2, or 0.5. Okay, so we have gotten the answer for part A. So how about B, the first term? The first term is A, right? So you just use this value, sub into the first equation or the second equation. So I think first equation is easier. So this is part A. This is part A. Now let's go to part B. Let me use another color. Substitute r equal to 1 over 2 into the first equation. So A 1 minus r equal to 10. So 1 minus 1 over 2, you will get 1 over 2. So this, you move it over here. 2 times 10, 20. Okay, so the value of A is 20. Okay, let me copy down the value for R and A first. Okay, let me go to the last part. Okay, let me erase this one first. What is the formula of sum to infinity? Sum to infinity. A 1 minus R, right? Okay, so A is 20. Okay, this is for this part, sum to infinity. So 1 minus R, R is equal to 1 over 2. 20 divided by 1 over 2, you can press the calculator if you don't want. Divide by 1 over 2 is actually equal to times 2 over 1, which is equal to 40. Okay, so this is the answer for these questions. Okay, so for this video, I just stop here first. Hopefully, after watching this video, you understand better about this part. See you next time, and thanks for watching. Bye bye.